Hi my friends. Now we'll create an assembly to create a dodecahedron, a regular solid of 12 faces. This is one of the only 5 regular solids possible. They are known from the Plato in 360 BC, and after him Euclid made a mathematical description of the Platonic solids in 300 BC. Let's make this, creating firstly faces, facets as solids, and then to combine them in an assembly. Let's go. I start with creating a facet. As you saw, that is pentagonal, a pentagon, 5 sides. I'll put it centered in the origin with this point on the same vertical with the origin, and only one dimension is enough, 25. Finish sketch. Very simple. And now extrude 2 millimeters, and I click here to apply 22 degrees of every side of this pentagonal facet. To create that dodecahedron, as I said, I'll select a material. Material could be, say, gold, why not? The aspect also gold metal, which will have a mass of 91 grams. We can afford it in CAD, computer-aided design. We can afford anything we want, be sure. Be sure of this. Okay, this is the part. Let's use it to create the assembly. To create an assembly, we open IAM template and we place, grounded at origin, a facet. I'll put another one, and I try to constrain them on an edge. For instance, I want to put here the edge, this edge. This is free and this is fixed. I cannot move it. I can move all the screen, of course, but the part in the system I cannot move. I told you about this. So I constrain, I use mate. I select this and this. I look very careful to see if they are how I want. Yes, they are. Okay, now let's see what mobilities have they. You can look to the degrees of freedom from view with this tool. We can move along the side, and we also can rotate this part, as you can see. The first thing I do is to mate this point with this point. So I go again to constrain. I select, you see, I don't see here the edges. This is why I select shaded with edges to have these lines visible. Now again constrain. You see, apparently I cannot select but only this edges, and I want to select the very vertex from here. If I wait a while here, it appears a possibility to select other than this edge, the other edge, the other edge, but also the vertex. This is selected. The other one is the vertex from here. Good. Okay, now what can we do? We only can rotate like a lid with hinges. So I don't insert here another constraint of angle. I bring another part identical with this one, of course, and I constrain it to be on the same on an edge of the same basic plate. Apply, and then another one with this one. Okay, now I am sure that this is a corner of the dodecahedron. Yes, I am very sure. This is equal with this, and we know that this object is formed with pentagons, one near the other. I cannot be wrong with this. Another place, and now I add all the other say 9, 1, 2, 3, 4, 5, 6, 9, all of them with all the 6 degrees of freedom free, but I don't want to see this always. I go to view again, and I disable this tool. Now I work very easy. I select this to put here, apply, and this here, apply. This one comes here, apply, but I cannot see the other edge, and this is okay. You see? No, it's not okay. This is why I want to create this, to show you how to change things when they are not very well chosen. Mate, edit this mate, and I choose the other. You see, here and here there are two different ways to put them together. If you try to make the same assembly, you will find very useful what I show you here. This with this, and apply. The other one comes here. Let's see what no, cancel, constraint, a side, an edge with an edge. Once again, this is the right position. Now constraint. You have to try to make what I do here. Now half of the dodecahedron is ready. I have to use the other 1, 2, 3, 4. Here are there are 5, 6. Oh, there is a necessary another 2. Yes, 1, 2, 3, 4, 10. Other 2 are necessary. Of course, these are 6, and here we have only 4. But the moment is not important when we place them here. Another edge with another edge. Let's see along it. Okay, apply, and this with this. Apply. This one with this one. Look at it. Okay, apply, and this one with this one. This is not okay. Cancel. Yes, we have to put it at an angle, not so, because it comes so, and it's not possible to put them side to side. We have to have this rotated so. Now we can constrain this edge with this edge. Okay, apply, and another one is this one with this. Apply. Let's see the position. I rotate it so, and constrain this edge with which one? This one. Apply. Another one, this one here. Apply, rotate to be so, constrain this edge with this edge. Apply. You see, two more facets are necessary to complete to 12. Place, facet 1, 2. Now constrain. If you tap the C from Constantine, C key from Constantine, then you can invoke this window, this cassette. Okay, I choose another edge to align with this one. Apply. Now let's see. Okay, constrain this with this, apply, and the last one is this one, to put over all, apply, cancel, and the last constraint. No, this is not okay. We have to edit the last constraint, edit, and choose this or not. Yes, this is okay. Constrain this with this, and the assembly is okay. The assembly has one kilo of gold. Very good. Now I'll show you something new. I have here the view ribbon, and I choose half section view. From here you have to select one plane, any one, for instance this one, and then to go to the object to see inside. Let's say this is the position. You see, this is what you can see inside if you take out the other part. To remove this facility, end section view is the solution. Now you have the full body. Another thing is you can choose any object from the list from here, right click and apply transparent, and now that facet exists. You see it here, but it is transparent. Yes. As you can see, Alt T is the shortcut. So anytime for any part in an assembly, you can click on it and apply. I apply Alt T, and now I see inside that assembly or behind the part, Alt T again after selecting, and the object is back. F6 to put it in isometric position, and I suggest you to try to create all these only five regular solids. This is with triangular faces, square faces, triangular, pentagonal, and another triangular. They are all the same. Bye bye.